Hi dear students, let us continue the next point, that is relations. In a previous video, people already came to know that what is meant by Cartesian product and what is meant by ordered pair. In this video, we just come to know that what is meant by relation or extension part. So here I just consider the two sets. Let A and B are the two non-empty sets. A and B are the two non-empty sets. A and B are the two non-empty sets. Then the relation R. R is said to be a relation. That is a notation for the relation is R. R is said to be a relation. This R is said to be a relation. When it becomes a relation, this is R is a relation. When it is a subset of the Cartesian product A cross B. It is a subset of the Cartesian product A cross B. I got my point. What is the relation? Let A and B are the two non-empty sets. Then R is said to be a relation. When this R is said to be a relation, whenever it is a subset of the Cartesian product A cross B. Already know the subset. Suppose A is equal to 1, 2, 3. This is the one set is the subset. What are the subset of this one? Singleton set 1 is the singleton set 2, singleton set 3, and two elements 1, 2, 1, 3, etc. These are all the subset of the given set A is there. In the same manner, A and B are the two sets are there. For this Cartesian product is that this is the Cartesian product. A and B are the several elements are there. Several order pairs are there. Out of these order pair, I am just taking the one of the subset of this Cartesian product. That is said to be a relation. For example, if you want to come to know that more elaborately, I just take a particular example. Suppose the set A contains 1, 2, 3 and the set B contains A and the B. So writing that Cartesian product A cross B. What is the A cross B? 1, comma A, 1, comma B, 2, comma A, 2, comma B, 3, comma A, 3, comma B. These are all the order pairs. 3 to the 6 order pairs will get N of A cross B. Now I need to get the relation. What is the relation? Relation is a subset of the Cartesian product. How many subsets we can write? Many subsets. How many subsets we can write? To write the number of subsets, it is a power set. Number of power set. What is the number of power set? 2 power m. That means 2 cube. 2 cube is equal to 8. 8 subset we can write for this set. Here, how many subsets we can write? Number of subset formula. How to find the number of subset formula? This is the formula to find the number of subset. How many? 2 power m. Where m is the number of elements which are present in the set A. Number of elements which are present in the set A. Here, in a what is the original set? Here it is the original set. Because relation is a subset of the Cartesian product. Relation is a subset of the set C. Are you clear? So that how many subsets we can write? We can write the 2 power 6. What is the 2 power 6? 64. 64 subsets we can write. All those 64 subsets are the relation. 64 are the relation. Is that clear? That we can come to know that laterwards number of relation. First of all, I just write one of the subset that I just name the relation R. I just name that R1. R1 is a relation. How this is that 1, comma A, 2, comma A. Is this a subset of this Cartesian product A cross B? Obviously it is a subset. 1, comma A, 1, comma A and 2, comma A. These two elements are present at here. So it is one of the subset. So this is the relation. Next, one more relation right. R2 I am just going to write. What is going to write means 2, comma B. Is it a subset of this relation? Yes. Is it a subset of this set? Yes, it is also a relation. Next, I just write R3. R3 is equal to, I just write 3, comma B, 1, comma A and 2, comma A. Is it a subset of this set? Yes. All these three elements are present in this set. Obviously, it is a subset. So, like that, how many subsets we can write this one? there are 64 subsets we can write. So these are all said to be a relation. What is the relation? A and B are the two non-empty set. Then the relation R is a subset of the Cartesian product. Two non-empty sets are there. Get the Cartesian product. For this Cartesian product, subset, whatever the subset are there, all those are the relation. Or any one of the value. This is the relation, this is the relation, this is the relation. Like that. It is a relation. Now, we just got the one point. What is that point? Note, I just take it. What is the note means? Number of relation. What is the total number of relation? What is the total number of relations? What is the total number of relation? If n of A is equal to m and n of B is equal to n. Set A contains m element, set B contains n element. Then what is the n of A cross B? N of A cross B is equal to m into n. Now I need to get the total number of relations. What is the total number of relation? Total number of relation is equal to 2 power number of elements which are present in n of A cross B. That is nothing but 2 power m, where m denotes the number of elements which are present in a set A, n denotes number of elements which are present in the set B. So, and apart from that, this is one first node, second node. Suppose here A and B are the two non-empty set, then the relation R is from set A to set B. Here particularly you can write from the set A to set B is a subset of the Cartesian product. As well as we just mentioned the definition. What is the proper definition? Means let A and B are the two non-empty sets. Then the relation R from A into B. Relation R from A to B is a subset of the Cartesian product A cross B. Is a right in words. A relation R is from A to B is a subset of the Cartesian product A cross B. That is right. That is then R is a subset of A cross B. I got my point. If you need, I just write the definition. Or else here it is an example. R1 is equal to 1 comma A, 2 comma A, and 3 comma. These are the examples for the relations. Take these are the examples. Definition is clear. One more time. Let A and B are the two non-empty set. The relation R is from A to B. From the set A to set B. Relation R from set A to set B is a subset of the Cartesian product A cross B. Is a subset of Cartesian product A cross B. That is symbolically. That is R is subset of A cross B. Proper subset of A cross B. Is that clear? Next one. Write the example. That note total number of relation is equal to 2 power m into n. Where n of A is m elements, n of B has a n elements. Then n of A cross B is m and n elements. Next one. Similarly, I just told you that in the definition from set A to set B, only single set is that. Suppose the set A is that relation R is from set A to set A. Relation R is from set A to set A itself. In that case, relation R is a subset of Cartesian product A cross A. Relation R is a subset of A cross A. Single set is given. In that case also, we can get the Cartesian product A cross A. Previously, you just know that Cartesian product we can find. Therefore, relations also can find. If you got the Cartesian product, collection of all the order pairs, then you can easily get the relation. Relation is a subset of the Cartesian product. Okay. Next thing is, so number of relations you have already mentioned. Next point is, suppose if you say that if A comma B is present in the relation R, if A comma B is belong to the relation R, then we can say that A is related to B. Then we can say that A is related to B. If order pair A comma B is present in the relation R, if the order pair present in the relation R, then we can say that A comma B is present in the relation R. How we can say that A is related to B? and we return it as, and we write it as A is related to B. How to read this one? Write as A or B. Read as A is related to B. Are you clear? Suppose one order pair is present in the relation R, then we can say that A is related to B. Write it as A or B. Suppose if the order pair A comma B is not present in the relation R, if the order pair A comma B is not present in the relation R, then we just say that A is not related to B. A is not related to B. A is not related to B. That means write it as A is not related to B. A or B. Just slash or write the slash on the R. Is that clear? A is not related to B. How to read this one? A is not related to B. Okay. Apart from that, these are the 2 points. Just remember, very important points. So till so far, definition is clear. What is the relation? Let A and B are the two non-intersect. Then the relation R is from A to B is a subset of the Cartesian product A cross B. A is a subset of Cartesian product A cross B. Then example, A has 3 elements, B has these 2 elements. Then few example I just written. Totally 64 subset we can write. Out of that all the relation. Then the total number of relation is 2 power mn, where m is the number of elements in the first set and n is the number of elements in the second set. Very important point. Remember, 1 marks question is going to ask based on this formula. Next, total number of relation is over. Then we can write the relation to the same set A cross A. A is one set is that A cross A we can write. Then we can write the subset for this Cartesian product. All are relations, that are the relation. And if the order pair is present in the relation, we can say that A is related to B. Write it symbolically, mathematically A or B. Read as A is related to B. If order pair is not present in the relation, write it as A or slash B. Read as A is not related to B. For example, for these 2 points, I just take the example. What is the example? Means R1 is that. Suppose, can I say that 1 comma A is present in the R1? 1 comma A belong to the R1. That means 1 is related to A. 1 is related to A. That means 1 is R1A. 1 R1A. That is nothing but 1 is related to A in the relation R1. We can write it as R1, no problem, because I am just writing several relations, so that is a different name I just given, R suffix 1. And apart from that, here 1 comma B, whether 1 comma B is present in the R1 or not present in the R1. 1 comma B, 1 comma B is not there, 1 comma B is not belong to the R1. 1 comma B is not belong to the R1 means what we can write? 1 R1 hash B. That means 1 is not related to B in the relation R1. 1 is not related to B in the relation R1. In the relation R1, 1 is not related to B. In this relation only it is not related. But 1 comma is present, 2 comma is there, 3 comma B. 1 comma B or 1 comma B is present in a different relation. Is that clear? This is all about the relation. And particularly these 2 note and these 2 points, just remember. Now the next point is, yes, next point is domain, codomain and the range of the relation. Already come to know that what is the relation. Now in this point we just come to know that what is the domain of the relation, codomain of the relation, range of the relation. You people already heard that domain, codomain, range. Domain and the range is the trigonometric functions. Domain of the trigonometric functions, range of the trigonometric function. That topic is comes here. What is exactly the meaning of the domain? We are going to come to know at this moment. Anyway, here function relation is the similarly the function also. Okay. Now I just consider relation because domain, codomain and the range of the relation is required. Okay. Let R be a relation. let R be a relation from the set A to set. Obviously, these two are the non-empty set. Let R be a relation from non-empty set A to non-empty set B. Then R be a relation means that is a subset of the Cartesian product A cross B. This R is a subset of the Cartesian product A cross B. Then R is a subset of the Cartesian product. I just write simultaneously one particular example. Suppose the set A contains 1, 2, 3. Set B contains A and B. Now, what is the Cartesian product of these two sets? Cartesian product is, I am just going to write all the possible order pairs. 2, A, 2, B. Next 3, A, 3, B. These are all the possible order pairs of the Cartesian product A cross B. How many subsets we can write? N of A cross B. What is the N of A cross B? That is N of A cross B is equal to 6 is that. Number of relations. What is the number of relations? Number of relations we can write as a 2 power 6. That means 64 relations we can write. Out of the 64 relations, I am just considering few relations here. What are the few relations we can discuss here? Means I am just going to write one of the relation R1 is equal to 1 comma A, 2 comma B, and 3 comma B. This is one relation I just consider. Second relation I just consider. Whatever the relation you can consider, no problem. 1 comma B and 3 comma A. This is one relation. R3 is equal to 2 comma A, only single element. These are the three relations I just consider. On seeing these three relations, let's come to understand that what is meant by domain of the relation, codomain of the relation, and the range of the relation. Very simple. First of all, domain. What is the domain of the relation? Domain of the relation is nothing but the first element of the order pair. In the relation R, the first element of the order pair is said to be a domain of the relation. What is the domain definition? The first element of the order pair of a relation. First element of the order pairs of a relation is said to be a domain of the relation. Okay. What is the domain of the relation R1? Domain is denoted by in this manner. Do D suffix R1. Domain of the relation R1. What is the domain of the relation R1 means? First element of the order pair. How many order pairs are there in the R1 relation? There are 3 order pairs are there. Out of the 3 order pairs, first element of the order pair. What is the first element of the order pair? 1. First element of the order pair 2. First element of the order pair 3. What is the domain of the relation? 1, 2, 3. The relation R1 domain is how much? 1, 2, 3. This is said to be the domain of the relation R1. Similarly, domain of the relation R2. What is the definition of the domain? First element of the order pair in a given relation. First element of the order pair in a given relation. Relation is here. In this relation, how many order pairs are there? All those order pairs, first element. What are those? 2 elements are there. For these 2 order pairs, first element 1 and 3. This is the domain of the relation R2. Similarly, what is the domain of the relation R3? Only one order pair is there. Out of that, first element of the order pair is this is the domain of the order pair. Is that clear? Particular example. Now, the general definition. What is the general definition? It is denoted by, write it as a domain, and we can write symbolically domain D suffix R. Generally, I am just giving the definition. What is the domain of the relation? First element is nothing but A. From where we have to choose? We have to choose from the order pair A comma B, which is present in the relation R. First element of the order pair which is chosen from the order pair A comma B, where this order pair must be present from the relation R. From the relation R. This is the representation, set representation in the particularly set builder form is that. This is our words. What is the word? The domain of the relation is given by the first element of the order pair from the relation. First element A is the order pair in first element choose ಮಾಡ್ಕೊಂಡ್ರೆ ಅದು ನಮ್ಮ domain. Already ನಾವು particular example R1 ಎಷ್ಟು order pair ಎಲ್ಲಾನು ತಗೋಬೇಕು. Suppose ಇನ್ನೊಂದು ಆರ್ಡರ್ ಪೇರ್ ಇತ್ತು ಇಲ್ಲಿ ಏನಪ್ಪಾ ಅಂತ R1 ಒಳಗ suppose for example where is that suppose 1 b ಈಗ 4 ಎಲಿಮೆಂಟ್ ಅದಾವ ಈ 4 ಆರ್ಡರ್ ಪೇರ್ ಒಳಗ ಫಸ್ಟ್ ಎಲಿಮೆಂಟ್ 1 2 3 ಮತ್ತು 1 ಅದ 1 ಅಂದಾಗ ಸರಿ ಬರುವಾಗ ರಿಪೀಟ್ ಎಲಿಮೆಂಟ್ ಅನ್ನು ಏನು ಮಾಡ್ತಾರೆ ನೆಗ್ಲೆಕ್ಟ್ ಮಾಡ್ತಾರೆ ಬಿಟ್ಬಿಡ್ರಿ ಇವಾಗ ನನಗೆ R1 ಡೊಮೇನ್ ಏನಿತ್ತು 1 2 3 ನ ಬರೋದು 1 2 3 ಮತ್ತು 1 ಬರೋದು ಏನಾಗುತ್ತೆ ರಿಪೀಟ್ ಎಲಿಮೆಂಟ್ ಅದ ಸೇಮ್ ಎಲಿಮೆಂಟ್ ಅದ 1 ಅದ neglect ಮಾಡಿ nothing to worry. Are you clear? So what is the domain of the relation? First element of the order pair is said to be a domain of the relation. Is that clear? Next, domain ಬಗ್ಗೆ ತಿಳಿಸಿವಾಗ domain clear ಆಯ್ತಲ್ಲ very simple. ಒಂದು relation ಇರ್ತದ ಅದರ ಆರ್ಡರ್ ಪೇರ್ ಇರ್ತಾವ ಆರ್ಡರ್ ಪೇರ್ ಒಳಗೆ ಫಸ್ಟ್ ಎಲಿಮೆಂಟ್ ಏನೇನು ನಾವು ಎಲ್ಲ ಬರೋಣ ಡೊಮೇನ್ ಬಂತು clear. Next, codomain. What is the codomain? Codomain of the relation. I just rub this one. I think you just got the point. Codomain. What is the codomain? Codomain is nothing but the second set of the Cartesian product is said to be a codomain. What is the codomain of the relation? The second set of the Cartesian product. What is the Cartesian product? A cross B. Is the relation is that relation is the subset of the Cartesian product is that I need to find the codomain of the relation R. Codomain of the relation R is nothing but the second set. What is the second set is that is our required codomain of the relation. That is our required codomain of the relation. Exactly. What is the codomain? Codomain is nothing but second set of the Cartesian product. Relation is defined from non-empty set A to non-empty set B. It is a subset of the Cartesian product A cross B. Out of these two sets are there. Second set is there. That second set is said to be a codomain. Whole second set is said to be a codomain set. Here we can write the whole set B is called a codomain set. Next, third, range. Range of the relation R. Range of the relation R is denoted by R suffix R. Capital R denotes the range, suffix R. Range of the relation R is reverse of the domain. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಡೊಮೇನ್ ಒಳಗ ಫಸ್ಟ್ ಎಲಿಮೆಂಟ್ ತಗೊಂಡು ರೇಂಜ್ ಒಳಗೆ ಏನು ಮಾಡೋದು ಸೆಕೆಂಡ್ ಎಲಿಮೆಂಟ್ ಆಫ್ ದ ಆರ್ಡರ್ ಪೇರ್ ಆಫ್ ದ relation R. Second element of the order pair. Second element of the order pair is nothing but B. B is the second element. You can write the general form. What is that? A comma B. Such that ಈ order pair ಎಲ್ಲಿ ತಗೊಂಡರೆ ಇದು relation ಒಳಗೆ ಇದು ತಗೊಂಡರೆ A comma B which is present from the relation R. This is the general definition of the set builder form of the relation. Now I need to come to know that range. Range is nothing but second element of the order pair. B ಎಲ್ಲಿಂದ ತಗೊಂಡರೆ ಆರ್ಡರ್ ಪೇರ್ ಅಂತ ತಗೊಂಡು ಈ ಆರ್ಡರ್ ಪೇರ್ ಎಲ್ಲಿ ಇರಬೇಕು ರಿಲೇಷನ್ ಒಳಗೆ ಈ ಆರ್ಡರ್ ಪೇರ್ ಎಲ್ಲಿಂದ ಇರಬೇಕು ರಿಲೇಷನ್ ಒಳಗೆ ರಿಲೇಷನ್ ಒಳಗೆ ಆರ್ಡರ್ ಪೇರ್ ಇರ್ತದ ಆರ್ಡರ್ ಪೇರ್ ಒಳಗೆ ಸೆಕೆಂಡ್ ಎಲಿಮೆಂಟ್ ತಗೊಂಡ್ರೆ ನಮಗೆ ರಿಕ್ವೈರ್ಡ್ ರೇಂಜ್ ಬಂತು is that clear what is the range of the relation the second element of the order pair from the relation R is said to be the range of the relation very clear particularly what is the range of the relation 1 range of the relation 1 is AB is the price but repeated elements are going right only once what is the range of the relation R1 A comma B range of the relation R1 is A comma B that's it range of the relation R2 B comma A or A comma B order is different next range of the relation R3 only A. Is that clear? Here we got the 3 points. What are the 3 points? Domain, codomain, and the range. What is the domain? Domain is nothing but first element of the order pair in a given particular relation. Domain. Codomain is nothing but whole set B is said to be a codomain. And range is nothing but second element of the order pair is said to be a range of the relation. Okay, next. Here, one already we just came to know that is A comma B is present in the relation R. Then we just write that A is related to B. You are right. And A is related to B. You are right. Here, one more word is that image of A is B. This you can write image of A is B. A is related to B. This is one way to write it or read it. A is related to B. Another word is that, another way is that, what is that? Image of A is B. Image of A is B. We frequently use this image that in the particularly function. We will come to know in the next videos. Anyway, just remember very important point. Name. Just the names are different names. Different person is going to use a different words. Obviously, everyone must use this one only. A is related to B. Another word is image of A is B. Now, based on these all things, let's take some example or particularly note here. What is the note? Is nothing but note. Here the note is all the relations can be expressed in the form of either set builder form or by the roster form. All the relations can be expressed. Whatever the relations we are writing, here we just return the relation in terms of the set builder form. Here we return the relation in terms of the roster form. We can write the relations either in the set builder form or in the roster form. That is the particular note. What is that? Every relation can be expressed in the form of set builder form or either in the form of roster form. This is a particular note. Now, based on these all the things, let's take an example. What is the definition of the relation, domain of the relation, codomain of the relation, range of the relation? Based on these all the things, take examples. First example, based on the definition of the relation and domain, codomain and the range of the relation. Let A is equal to 1, 2, 3, 4, 5, 6. Define a relation R from set A to set A by R is equal to x comma y such that y is equal to x plus 1. First case, depict this relation using an arrow diagram. Second case, write out the domain, codomain and range of the relation. First of all, what is the given? Whether they are given a relation or not, check it. Solution, and this will write. What is that? Set A is given. First of all, write the given things. Set A is given. What is the elements present in the set A? 1, 2, 3, 4, 5 and 6. Total, how many elements are there? 6 elements are there. On this set, here set B is not given. As we know that relation is a subset of the Cartesian product A cross B. As well as we can write relation is a subset of the Cartesian product A cross A. Because we can write the Cartesian product A cross B as well as we can write the Cartesian product A cross C. Nothing to worry. Here B set is not given, only A set is given. We can write the A cross A. Now here, how many elements are there in A cross A? A cross A, how many elements? 6 into 6. That means 36. Number of relations. How many number of relations we can write? Number of relation formula. What is the number of relation formula? 2 power mn. M is nothing but number of elements in the set A. N is nothing but number of elements in the set B. That means 2 power 6 into 6. Both are same set. That means 2 power 36. See how many relations we can write. 2 power 36. There is very large number. 2 power 36. Is that clear? So that there are so many finite is that so many relations we can write. Out of that relation, 2 power 36 number of relations, one relation is given. How that relation is done means already we know that A comma B belong to R is nothing but A is related to B. How the A is related to B? How the A is related to B is nothing but mathematically we can say that. For example, whether A is equal to the B is that, or A is greater than B is that, or A is less than B is that, like that. Whether A is equal to the B square, whether A is equal to the B power 10. How that these two values are related? That relation is A is related to B. How that relation A and B is nothing but they given a manner. Instead of giving A comma B, here they are given X and Y. How the X and Y is related? X and Y are related in such a way that y is equal to x plus 1. X को y को संबंध नहीं y is equal to x plus 1. x ಗೆ 1 add ಮಾಡಿದಾಗ equal to the y ಆಗುತ್ತೆ. For example, x value 1 ಅಂತ ತಿಳ್ಕೊ, y value ಏನಾಗುತ್ತೆ, x value 1 ಆದಾಗ y value 2 ಆಗುತ್ತೆ. ಯಾಕಂದ್ರೆ x ಗೆ 1 add ಮಾಡಿ. This is how the x and y are related. X is related to y. How the x is related to y? Y is equal to x plus 1. This is how the x and y are related. Have you got the meaning of the question? Okay, I hope you just got the meaning of the question. Anyhow, now here one more thing. This relation is in the set builder form or roster form? Set builder form is the better to convert into a roster form. What is the roster form of the relation? R is equal to. How to convert into a roster form is nothing but if I replace the x and y, here both we can mention it x and y, and x and y belong to the set. What is the set? Belong to the set A. X will y value ಏನು ತಗೋಬೇಕು, ಈ ಫಸ್ಟ್ 6 ನ್ಯಾಚುರಲ್ ನಂಬರ್ ತಗೋಬೇಕು. ಯಾಕಂದ್ರೆ x y ಎರಡು ಸೆಟ್ A ಒಳಗೆ ಇರಬೇಕು ಗೊತ್ತಾಗ. x value 1 ತಗೊಂಡಾಗ y value ಏನಾಗುತ್ತೆ, replace here x value is 1, what is the y value? If x value is 2, what is the y value? 3. If x value is 3, what is the y value? 4. If x value is 4, what is the y value? 5. If x value is 5, what is the y value? 6. If x value is 6, what is the y value? 7. Here both x and y must belong to the set A. Whether 7 is present in the set A, 7 is not present in the set A, so that this order pair is not present in the relation. Only these order pairs are present in the given relation. ಇದು ಒಂದು relation. ಎಷ್ಟರೊಳಗೆ ಇದು ಒಂದು relation? Out of 2 power 36 number of relation, one relation is given. What is that relation? This is that relation. This relation is in the set builder form. I just converted into roster form. These order pairs are present. Once if we got this relation in terms of roster form, we can easily get the domain, codomain, and the range. Because what is the definition of the domain? First element of the order pair. What is the codomain? Second set, whole set B is said to be a codomain. What is the range? Second element of the order pair. We can easily write it. Okay. Second case you can easily write. Domain you can write, codomain you can write, range you can write. Simple. Okay, before that, first case is done. What is the first case? Depict this relation using an arrow diagram. We need to express this relation in terms of the arrow diagram. How to express in terms of arrow diagram is in this way. We have to write the arrow diagram. What is this? Is nothing but these are denotes the set A to B. Instead of A to B, here A to A is the set. A relation is that relation is from set A to set A only is that relation is from set A to set A is that. What are the elements which are present in the set A? Set A elements are 1, 2, 3, 4, 5, 6. Again, in place of set A, B, set A another 1, 2, 3, 4, 5, 6. Arrow diagram is equal. In our already given A comma B is present in the relation R is nothing but A is related to B. A is related to B another. Idu A, idu B another. One is related to what? One is related to 1 is related to 2. 1 is related to 2 comma 3. 2 is related to 3. Next 3 comma 4. 3 is related to 4. Next 4 is related to 5. 5 is related to 6. This is the required arrow diagram. This is the required arrow diagram of the given relation. E relation to arrow diagram is ಮುಗಿತು step. ಇದೇನಂತ ನಾವು ಇದು set A, ಇದು set B. Set B place ಒಳಗೆ ಏನದ? Again set A is the. This is the relation called as a arrow diagram. With the help of this arrow diagram, we can easily find the domain. What is the domain? Don't write all the elements. First, what are the elements are related? What are the elements has the images? I have already told that A is related to B and image of A. One more word I just told that image of A is B. What is the image of 1? Image of 1 is 2. Image of 2 is 3. Image of 3 is 4. Image of 4 is 5. Image of 5 is 6. 6 do not have any images. Is that clear? One more word functions ಒಳಗೆ ಇದ್ರ ಬಗ್ಗೆ images ಬಗ್ಗೆ ಜಾಸ್ತಿ ಕಲಿತ್ರಿ ಇದಿಷ್ಟು ಸಾಕು ಬೇಸಿಕ್ ಐಡಿಯಾ ಇದ್ರೆ ಸಾಕು thank you anyway so this is a arrow diagram ಈಗ ನಮಗೆ ಡೊಮೇನ್ ಗೊತ್ತಾಯ್ತು ಡೊಮೇನ್ ಅಂದ್ರೆ what are the elements has the images what are the element has the images ಯಾವ ಎಲಿಮೆಂಟ್ ಇಮೇಜ್ ಅದಲ್ಲ ಆ ಎಲಿಮೆಂಟ್ಸ್ ಎಲ್ಲ ಏನಾಗುತ್ತೆ ಡೊಮೇನ್ ಅಂತ which element has the images that is our required domain arrow diagram ಇದ್ದಾದರೂ ಡೊಮೇನ್ ರೇಂಜ್ ಬರೀತೀರಾಗ್ತದೆ okay what are the elements has the images that is our required domain whole set b is said to be the codomain ಇದೆಲ್ಲ ಪೂರ್ತಿ ಸೆಟ್ ಇರುತ್ತೆ ಕೋಡೊಮೇನ್ ಇಮೇಜಸ್ ಇದು ಯಾವ ರಿಲೇಟೆಡ್ ಅದಲ್ಲ ಅವಷ್ಟು ನಮಗೆ ಏನಾಗುತ್ತೆ ರೇಂಜ್ ಆಗುತ್ತೆ ಬಿಕಾಸ್ ಸೆಕೆಂಡ್ ಎಲಿಮೆಂಟ್ ಆಫ್ ದ ಆರ್ಡರ್ ಇದನ್ನ ಏನು ಬರೀಬಹುದು 1 2 3 3 4 4 5 5 6 okay arrow diagram is over depict this relation using the arrow diagram okay over next we need to learn the domain of the relation what is the domain of the relation domain what is the domain domain of the relation r is equal to r is here first element of the order what are the first element one is the 2 3 4 5 this is our required domain of the relation first element of the order pair of the relation is called the domain domain is clear next codomain what is the codomain codomain is nothing but over the set B whole set second set is said to be a codomain second set ಯಾವುದು relation is defined from R A to A that is R is a subset of A cross A second set is the A that means 1 2 3 4 5 6 this is our required codomain next range of the relation what is the range of the relation range of the relation is nothing but second element of the order pair what is the second element 2 is that 2 3 4 5 6 2 3 4 5 6 is our required range of the relation this we can also write it as DOM of R that means domain of R and range is also called as RENG range of R either you can denote domain of R range of R or you can write D suffix R R suffix R that is understood either this one or this one as per wish nothing to worry okay this is very important problem most of the time ask this one for 3 marks for writing this arrow diagram 1 marks writing this one 1 marks and writing the range 1 marks okay obviously if any one of the thing is mistaken then we will lose the 1 marks is that clear so very important and very simple things are you clear about the domain codomain and the range and as well as the relation definition what is the relation definition relation is a subset of the Cartesian product A cross B where A and B are the two non-empty sets. Domain is nothing but first element of the order pair. Codomain is nothing but whole set B is said to be a codomain. Range is nothing but second element of the order pair. And if the element order pair is present in the relation, write it as A comma B belongs to R or A is related to B. And if it is not present in the relation means A is not related to B. Then number of relations to power m and where m is nothing but number of elements in the set A n is nothing but number of elements in the set B we can write relation from A to A or A to B as whatever the manner okay now come to the next example this is a problem from the Cartesian product and order pair one problem is left I just solving here and then remaining problems of the relation will continue in the next paper. Let A and B are the two sets. A and B are the two sets are there. How that set is that is such that n of A is 3. Given that number of elements in the set A is 3. Set A consists of 3 elements. And n of B is 2 elements. Set B consists of 2 elements. Okay. That if x comma 1 order pairs they are given x comma 1 y comma 2 and z comma 1. If x comma 1 y comma 2 and z comma 1 are in a cross B okay A cross B Cartesian product contains an order pair x comma 1 y comma 2 and z comma 1 okay in A cross B find A and B where x y and z are distinct elements these x y z are distinct elements different elements are there so x y z are distinct element Set A contains the 3 element, set B contains the 2 element, and Cartesian product contains an order pairs x comma 1, y comma 2, and the z comma 1. In that case, what is the set A is equal to and what is the set B is equal to? We are required. Set A contains a 3 element, set B contains a 2 element. Okay. Cartesian product definition we know that. What is the definition of the Cartesian product? A cross B is equal to A comma B such that A belongs to the set A, B belongs to the set B. First element of the order pair belongs to the set E. Second element of the order pair belongs to the set B. That's all. Already order pairs of the Cartesian product is given. We are required to find the set A. First element of the order pair. What are the first element of the order pair? X, Y, Z. First element of the order pair over. Set A contains how many elements? X, Y, Z. All are distinct. That's all. Set B. What is the set B? Second element of the order pair. What are the second element? 1, 2, 1 is that. 1 is repeated. So neglect and write only once. 1 comma 2. Set B contains 2 elements. All the conditions are satisfied. Check it. N of A is 3. N of B is 2. Set A contains 3 elements. Set B contains 2 elements. And Cartesian product is contains these order pairs. According to the definition, I just got the value of set A and the set B. That's all. Very simple. It is a 1 marks question. Find the set A and the set B. Set A is x, y, z. Set B is 1, 1. Very simple example. Okay. With this problem, this is a problem from the Cartesian product. Previous video. Anyway, I just solved here and remaining problems of the relations as we solved the first one. Y is equal to x plus 1. In that manner, remaining problems will be going to solve in the next video. Okay. Thank you.